Hi, myself Jawaharlal, lecturer in electrical engineering. Today I am going to discuss about the armature reaction. Please like and subscribe my channel for the next videos. Here we see, first of all we discuss about the magnetic neutral axis and geometric neutral axis. Magnetic neutral is also called the MNA, may be defined as the axis along which no EMF is generated in the armature conductors as they move parallel to the flux lines. Brushes are always placed along the magnetic neutral axis because reversal of current in the armature conductors takes place along this axis. Geometric neutral axis or GNA may be defined as the axis which is perpendicular to the stator field axis. Now we come to the armature reaction. What is armature reaction? The effect of magnetic MMF set up by armature current on the distribution of main field flux of a DC machine is called armature reaction. The armature magnetic field has two effects. First, it demagnetizes or weakens the main field flux, and second, it cross magnetizes or distorts it. Now that we come, what is the effect of the armature reaction? First, here you see weakening of the main field flux. Weakening of the main field flux reduces the generated voltage in case of DC generator and reduces the torque in case of DC motor. And this is due to the demagnetizing effect of armature reaction. Second, the distortion of the main field flux. Distortion of the main field flux shifted the magnetic neutral MNA axis. Brush should be placed on the MNA axis, otherwise it will lead to sparking at the surface of brushes. So for a loaded DC generator, MNA will be shifted in the direction of rotation. On the other hand, for a loaded DC motor, MNA will be shifted in the direction opposite to that of the rotation. Third, the armature reaction induces flux in neutral zone, and this flux generates the voltage that causes the commutation problem. Again, the next we will discuss about the explanation of the armature reaction. Now here we consider the two-pole machine, and under no load condition the armature cluster does not carry current. So the main field flux is distributed symmetrically with respect to the polar axis. Here we see the main field flux from north pole to south pole, and that is distributed its polar axis. And OFA is the vector represents the magnitude and direction of MMF producing the main flux. In the next slide, you see here we consider the armature winding alone. The armature conductor to the left of the GNA carry the current inwards, and right to GNA carry currents in the outward direction. This current will set up a magnetic plus lines in the conductors. So it is clear that armature flux is directed downward parallel to the brush axis. The vector OFA here, vector OFA represents the magnitude and direction of MMF producing the armature flux. So these two are the single. First you have seen there is no current, and second is only the armature current. So third, you see in the above we consider both the flux and separately, which is not in the case. In practice, when the generator is loaded, the main field flux and armature will act simultaneously as shown in the figure below. As you can see from the diagram, the interaction of flux distorts the uniformity in the field flux. The resultant MMF vector OF. Here the resultant OF is the resultant vector is the sum of vector producing the main field flux OFM. This is the OFM. This is the main field flux, and MMF vector producing the armature flux OFA, and the downward direction is the OFA by the armature current. Since MNA is always perpendicular to the resultant MMF, the MNA shifts through an angle say theta. So यहाँ पर now you see the MMF is shifted through angle theta. So this is the OFM and this is the OFA, and the resultant is OF. So MNA angle is shifted to angle theta. Now in the next, here you see the brush also gets shifted to a new position and lies along with MNA. The brush position shifts in the same direction as the direction of the rotation of the armature. This will cause the redistribution of armature conductors and hence armature current. Some armature current under the influence of north pole will come under the influence of south pole and vice versa. It is so. Here the new magnetic neutral axis is shifted here. So the some armature conductor which is in the influence of north pole, this will come in the influence of south pole. And some armature conductors which are in you see here the influence of south pole, now they come here the influence of north pole. So OFA is redistributed like this, OFA, and this OFA vector is resolved into two parts. One is the OFC and second is the OFD. This vector OFD is opposite to the direction of flux of the main field flux. So it demagnetizes or weakens the main field flux. Now the OFC, which is in the perpendicular direction of OFD, and this is perpendicular to the main field flux, so it distorts the main field flux, and this is the cross magnetizing effect of the armature reaction. So you see in the next I have written here, then the vector OFA can be resolved into two components, OFD parallel to the polar axis and OFC perpendicular to the polar axis. And the horizontal component of OFD direct opposition of OFM. This has a demagnetizing effect on the main field flux, hence called demagnetizing component or weakening component of armature reaction. The vertical component OFC is at the right angles to OFM. It distorts the main field flux and so called cross magnetizing or distorting component of the armature reaction. This is all about the armature reaction. In the next, please subscribe my video and like my video. Then in the next topic I will come with how to reduce or minimize the armature reaction. Thank you.